Hi, welcome to readmeproject.com. Now we are going to see the process of a toolkit for modeling and simulation of real-time virtual machine allocation in a cloud data center. Here is the abstract of our process. In this paper, to propose CloudSet, a new generalized and extensible simulation framework that enables seamless modeling, simulation and experimentation of emerging cloud computing infrastructures. To address the problem of simulating scheduling algorithms in cloud data centers, to evaluate their performance for different metrics. So, to propose CloudSet for dynamic resource scheduling in cloud data center. The simulation framework has the following novel features. The first one is support for modeling and instantiation of large-scale cloud computing infrastructure, including data centers on a single physical computing node and Java virtual machine. Second one, a self-contained platform for modeling data centers, service brokers, scheduling and allocation policies. Third one is availability of virtualization engine, which aids in creation and management of multiple independent and co-hosted virtualized services on a data center node. The resource scheduling in infrastructure as a service is one of the keys for large-scale cloud applications. CloudSet treats multi-dimensional resources such as CPU, memory and network bandwidth integrated for both physical machines and virtual machines for different scheduling objectives. It provides better assessment for evaluation and modeling of cloud environments and applications. Let's move to one DFT of our process. In that first, resource initialization process. In resource initialization process, we have to create cloud data center, VM and number of jobs, number of users and number of cloud data centers. So these are the installation process for resource installation process. Then move to VM installation. In VM installation means we have to create number of virtual machines for the user request process. Then it moves to user request submission. Here the user create jobs cloudlets for the VM to create the submission process of. Then moves to load scheduling. In load scheduling we have to load the VM efficiency and allocate the user jobs to the free memory of the CPU scheduling process. Then moves to using LIF algorithm. In LIF algorithm it evaluates the VM scheduling process. The scheduling process utilizes the jobs and saves the resources and utilizes resource very well. And moves to a resource utilization process and finally evaluate the energy consumption process. Let's move to one demo of our process. A toolkit for modeling and simulation of real-time virtual machine allocation in a cloud data center. By clicking data creation, we have to create number of data centers in our process. 5 data centers are created successfully. In data center, number of machines, host ID, number of processing elements and RAM and also bandwidth is also initialized process of data centers. Then moves to broker creation. Here by clicking broker, the number of brokers are created, so the 4 brokers created with their broker ID. Then moves to next process. Here by clicking VM creation, the number of VMs one we created. The VM creation is 5. The 5 virtual machines created successfully. So VM ID, then broker ID, minimum instruction per second, then initial RAM and bandwidth. Then cloudlet creation. The cloudlet is same as jobs. The number of jobs we created is 4. So the 4 cloudlet jobs is also created. Then moves to the next process. In next process, we have to schedule the jobs in that process. The scheduling process, by clicking scheduling, the jobs should be scheduled. by the ID, unique ID and bandwidth, RAM, minimum instruction per second and number of processing elements. Here the cloudlet ID, broker ID, number of VMs and total load for each VM is also scheduled. Then moves to next process. Here by clicking compute load means load is computed. Here the ID, length, file size, output size, number of processing element and total length is also scheduled. Then moves to one load utilize process. Here the load utilize by clicking load utilize. Here the broker ID and number of cloudlets and load efficiency for each jobs are also utilized here. Then moves to one imbalance level. Then imbalance level we have to calculate the average imbalance level for VM and allocate the jobs to that VM. Here the VM, RAM, bandwidth, CPU and average load also calculated and allocated the jobs to each and corresponding VM and the average utilization. Then average utilization ID is also shown in the process. Then moves to one energy utilization. By clicking energy consumption, the average VMs and also the energy level of each VMs is also evaluated here. Then moves to efficiency of our process. Here by clicking efficiency, we have to show the CPU utilization of virtual machine allocation process is shown in here. Minimum instruction, processing element, CPU time and VM ID. So these are the efficiency evaluation of each VM process. Then moves to execution time. The execution time shows the efficiency of our process, CPU utilization time and also the memory utilization of our process before the load balancing and after the load balancing concept. Thank you.